Welcome everyone. Thank you for joining us. I Dr. Akhilesh Shatoria on the behalf of School of IT, AURO University. Would like to welcome you all for the webinar on Transport Protocol in Direct Storage System. Today we have an eminent guest speaker with us, Mr. Devesh Rai, Senior Technical Architect, Toshiba Software India Private Limited. He worked extensively in storage domain as a designer, developer and architect. He has also worked on distributed SAN file system, SCSI and block layer, SAS, SATA, PCIe driver in past. Currently he is working as architect of non-volatile memory express, solid state drive over peripheral component interconnect express. Today he is going to talk about technology driven world where old barriers are being breached and new goalposts are being set. Mr. Devesh will inform how to transport protocol used by drive can have such a significant impact in coming year. Now, without further ado, we'll turn over to Mr. Devesh Rai. Mr. Devesh Rai, sir, please. Sir, now it's over to you, sir.
Hello.
Devesh,
am I audible?
Yes, sir. You are audible, sir.
Okay. Thank you. So, thank you, Dr. Latoria, and I get an immense pleasure to join this session, and I would like to thank Dr. Bhanu for inviting me to have this webinar, and and he told me that there is a series of webinar going on in AURO University, and I would like to thank Dr. Goswami and Dr. Latoria for having me over here. And I would also like to thank all the students that who joined this webinar, and I would anticipate now that they will bear with me for next maybe 30-35 minutes, because our time has been curtailed a little bit, but whatever is left, let's make out of the best of that, I assume. And then I will like to start this presentation. Okay, so thank you for joining, everybody. Let's start. Today I'm going to talk about the transport protocols which is being used in some of the storage devices, and and we are going to discuss about that how these storage protocols matter in today's environment, and why some of the old existing which we are so much aware about, why they will not fit in the future scheme of things. So this is my agenda to talk about like serial advanced technology attachments, like all you 3 points you can read, but these are the very big names, all right? And like you must be thinking that what is my agenda actually? Am I going to confuse you guys, or am I going to make you confounded? Well, in lockdown period, that is not a good idea, right? So I'm going to say that this is what I'm going to discuss. Now, this maybe looks a familiar name, right? The SATA, SAS, and the PCI. So these are the three commonly used protocols used by all hard disks, and nowadays, like you must be aware about SSDs, right? Those SSDs are coming into your desktop, your laptop. So this is today. This is the topic we are going to discuss about it, and but before we start, protocol discussion about protocol level can get very boring. So, but first of all, we need to understand that how these things will be used in the real world, right? Otherwise, like technology in its isolation is not a true depiction that how it is going to be used, how it is going to affect each and every one of us, or in how it is going to affect the society in a whole. So I thought about like a very simple use case. So first we will discuss about the use case that these what is the use case where we are going to use the data and how we are going to use the data. Then it makes sense to talk about that how this data is going to be delivered to the end user, and how this data is going to be fetched from the storage where data is stored. So let's talk about use case. So I think most of you have heard about Jedi. Remember the Jedi? Well, I will give you a hint. Well, this is the famous sword of Jedi. Now I think that some of you might correlate with it. Actually, my son played with this sword, and this is a movie which was, I think, was released some time back, and the movie was the last Star Wars Jedi, the Last Jedi. Well, we are not going to talk about Star Wars, but yes, of course, we are going to talk about Jedi. That why this term makes basically significance. Why this term is significance in for the storage. So let's remove like. So this is what we are going to talk about Jedi. Jedi is the Joint Enterprise Defense Infrastructure. This is a proposed American military cloud services. So remember, like American military, and this is all other details about Jedi. So, well, why we are talking about American military cloud services? Remember that American military is one of the most advanced user of technology in the world. The whole internet thing came, IP and everything came because of military. They started. They needed some communication mechanism across the globe, and they wanted to share data across the globe. So that's why they from there it all came, like ARPANET and everything. So this is a very significant step for the storage industry, because although in today's world there are so many advanced users, that this is no longer a monopoly of American military, that how the data is being stored and how data is going to be used. But still, they threw some challenges before the industry, before whole storage industry, and it is very interesting that how industry is geared up to solve those challenges, and not only military applications, there are applications on the society itself. Like later on, all this military hard technologies later on turn to be helpful in the society in some way or other. So just this is a $10 billion deal, cloud services, for the cloud services of military, American military. American military spends around more than $720 billion so per year. So this is 10 billion is nothing, but still this is just a step that they have taken, and probably they are asking that they want this cloud services by 2021. So what is the things they want? Like you can read in the stated objective that this is the objective. They made it public that this is what they want, like preparing their workforce, combat forces in time of internet of everywhere, internet of things, and they want enterprise cloud solution. So the key word here is the enterprise cloud solutions. There are many clouds today. like but when you store something on the cloud, it is so hard to get data in a fast and reliable manner, because it takes time. Once a data goes to the cloud, today's cloud is a little bit slow. But that is not the requirement here. They want enterprise cloud solutions. So yeah, someone is raising hands. Okay, so we'll proceed further. So before going to going detail about, so there is another, like you can see that these two soldiers wearing two headsets, and these are the headsets. So what is the use case? What is the use case of these headsets? These headsets are basically, they call it integrated visual augmentation system, and this is based on HoloLens 2, and this headset was developed by US Army. But you can search the net. HoloLens 2 is basically designed and developed by Microsoft. These are the very expensive headsets. It comes around like $3,500 a piece, and these are basically prototypes. And how they are going to use, basically it is just they are exploring that how these things can be used. Remember the movie Matrix, where someone wanted to fly helicopter on the run, so they asked someone on that, okay, program, give me how to fly this helicopter, and immediately a program comes, and the person standing there knows that how to fly a helicopter. So are these headsets going to be that advanced? We don't know. Right now, it is just a prototype devices. It is in the market, and how they are going to use it, like they are experimenting everywhere. Can a doctor use this HoloLens devices to do a complex operation in a very remote location? So all this, there are so many applications they are trying. But at the same time, US military is also toying with these HoloLens. So what is their objective? Well, we will see in couple of next slide, probably next slide. So HoloLens is, as I said, it is a Microsoft headset, and it is well integrated. It is a connected device integrated with the cloud, and it is the Microsoft cloud, as you must be knowing, everybody, is that they call Azure technology. And US military gave this 10 billion Jedi cloud project to Microsoft. So now you can think of the situation that US military already using, like they plan to use around more than 100,000 of these headsets by 2021. At the same time, they want this Jedi project to be up and running in US military by 2021. So, and this is just a cloud technology, which is Microsoft calls them, and this is what they are proposed to use in Jedi cloud project. At the same time, now Jedi has gone into some trouble because of there is another leading player, Amazon, and Amazon is basically saying that they can deliver better product. So this project is a little bit delayed, but it is still going on. Okay, so we have two components over here. Is that one is Jedi cloud project, and another is that this is HoloLens 2 EVA's headset based on HoloLens 2. So how they are going to use this? So how American military is going to use this two things, what they are planning, and they are planning not so far. It is like just like a couple of years from now, and they are planning to use this. So this is just a very simplified use case I could come up with. Believe me, there are a lot of things between these dotted lines. There is a lot of other technologies which fits between these two blue lines, but this is just two ends of one whole big system. One is that there is a storage servers and there is a EVAS devices connected with the cloud. Now let's have so now you can see that there are two endpoints of this whole entire spectrum. One is the storage devices, and another endpoint is basically two soldiers using this headset, and they are basically, these headsets enables them to connect with any data which is stored on these storage devices through cloud. The question is that how they are going to access this data. Well, there is a new technology coming up, and I think that you all must be aware about it, is that 5G. So 5G technology is coming. Currently we are at 4G. Everyone is using in their mobile drives and mobile devices, and everywhere this 4G technology is being used. Now they are proposing to use this, like American military wants to provide some data to their soldiers on the ground using 5G devices and through this HoloLens. Whatever data, like they want to map what type of data is basically based on the what kind of uses or what kind of situation these soldiers are. But the important point from the storage perspective is that from storage devices all the way, these storage devices can be anywhere in the world, these soldiers can be anywhere in the world, and there are whole set of solution lying between them, and this whole system is fetching data, analyzing for them, and giving them the real-time data so that they can decide, they can take very precise decision at the ground. So now you can see that, so this is a real-time data analysis, right? So it never happened before, because we didn't have technology to access these data so fast. In current world, there is no such storage devices which can basically fetch the data at that speed, and at the same time there is no communication protocol exists today that even if data is there, that how to relay it at the real time. Okay, so there are real-time applications like data being forwarded using satellite, but it is not for the common man. It is too costly. So now so this is the use case. So I will just give you a hint that not a hint, but I will give you a point to think about, is that there are 2 points at the end of a spectrum. One is the storage drives, and one is the 2 soldiers, and then there comes a storage protocols. I'm sorry. Okay, So now it makes sense that, well, if we can say that there is a, like, 5G is going to be very fast uh, communication method, and at the same time there are storage devices with the, like, which can give you a lot of throughput. Then what is the transport? So is today's transport is optimized enough to can provide can feed the data from storage devices to the cloud storage backbone, so that these data can be transferred to these two soldiers over communication channel. So that is why I thought to discuss about, like, these transport protocols, which is today known as, like, they are widely currently used everywhere in enterprise world, because remember we are talking about enterprise cloud solutions. Okay, so in enterprise world, these are the, what is SATA, SAS and PCI, these are being explored and how they are getting used. This is what we are going to discuss today about. This is why we are going to discuss about SATA, SAS and PCI transport protocol. Okay, so, well, we will move ahead. Well, one thing, like, you must have seen that, like, President Trump going over the top of his voice, warning all his allies that do not buy anything from China for the 5G network. Remember, like, sometime back, why this is, like, US is so worried about 5G, any country using 5G technology from the China. What's there to basically to make such a huge uproar about it? So I will give you just an example that sometimes back, like a WikiLeaks, right? And there it came out that US has capability to snoop on any mobile device in the world. In fact, they snooped on the German Vice Chancellor as well. So, sorry, not Vice Chancellor, I don't know what, probably German President or somebody, like, say, head of the state of Germany, and they snoop on her mobile as well. So how that was possible? That was possible because in today's world, US is controlling authority of internet and of 4G technology. So anything which is being transmitted anywhere in the world on these communication channels, US has capacity and capability to trap it. Well, there are encryption logic and everything, but the governments can force these companies to share the encryption keys with them. So now you know that why in 5G technology, when world is going to adopt the new technology, US is asking its allies that not to use this technology taken from China, because they are worried that if whatever data is communicated to soldiers on the field, and if it is captured or snooped by China, so lot of hole in their strategic doctrine, right? So this is why you can see that why US is making so much hue and cry over 5G technology. Okay, so coming back to our transport protocol and coming back from the world of politics, let's focus on the So before we go there, so this is storage devices, right? Storage devices are basically right now, in terms of many type of storage devices are being used. One is like hard disk, as we know, the traditional storage device, and nowadays it is like SSD, solid state drives. So we, as I said earlier, that we are talking about enterprise storage. In enterprise storage, and what is the 5G effect? So okay, let's talk about 5G effect first. So this is the estimate of industry. Basically, the left-hand side graph is a case study is done by IDC, and this case study was started by I guess no, it's Seagate. So Seagate wanted to know that how data will be used by 2025, and the IDC came up with saying that okay, from 2000 by this is 2017, we are around, world is using around 20 zettabyte of the data, but by 2025 can see that around 175 zettabyte of data will be used. So these much data need to be stored, these much. And but this study also came up with a very interesting fact, and which is that like 50 zettabyte of data by 2025, this much data will be used in the real time. So now you can see that 43% cumulative annual growth of real time data demand. Nowadays, what is the max real time data demand? Like we are watching Netflix, and now on the 4G, thankfully it is not basically going through all those buffering. We remember, right? Sometime like before 4G, like if you watch a YouTube channel or anything, data like you must be getting like buffering or something like that. That was handled by 4G to an extent. Not in India, but elsewhere in the world, it is handled by 4G. But still, that is not a real-time data growth. Now there is a prediction that by 2025, actually the 50 gigabyte of drive will, so that is coming around 1/3 of the total data, will be used in real time. Okay. Now the second graph shows that how this enterprise storage will move on. So you can see that, like, I don't know, you can see it is, these thumbnails are totally clear or not, but you can see that hard disk is still will be capturing around 80% of the data, because there is a reason, because hard disks are cheap. The solid state drives are basically very costly. So it is around like the cost of acquisition, cost of per gigabyte is around, I think it is more than it's 8 to 10 times the hard between per gigabyte comparison between solid state drive and the hard disk. So that is why you still see, because world needs to store 175 gigabyte data by 2025. So there will be a market for hard disk, which is slow storage drives, and at the same time there will be just guys, give me a minute. Hello. Yeah. Okay. Yes. Give me 10 minutes. 10 minutes. Sorry guys, there was a reminder. Okay, this is the time. Okay, so we are running out of the time. But anyway, so let me go through it quickly. And well, we have not started yet. Okay, anyway, so this kind of data and how this data will be stored across different kind of drives, and this graph gives you that how much data there is. You can see that a very interesting point is like from 2015 you can see that there is a green and blue color graph bars, and the yellow color bars basically is hard drives which are storing cold data. Now I think that from the cloud perspective, you know that what is the cold data. The cold data is that data eventually you need it, but you don't need right now. For example, like in general, very practical uses case. So you have around like 10 years, you are accumulating 10 years photographs for the last 10 years. But some of the recent photographs you want to share, you want to like share on Facebook or anywhere. But down the line, 10-year data you do not want to share, do not want to access so frequently. So storage cloud where you are storing your data is tend to move those data to these yellow drives, which is represented by these yellow graphs, and the blue graphs was the hard disk, which was supposed to perform much better in performance wise, but those are basically getting replaced by SSDs now. So I'm sorry that how we are going to our time is over. So how do we hello? Are we going to continue or hello?
You can continue, sir. If you need a time, you can continue.
Sorry, I cannot hear you. Hello?
Sir, if you need a time, you can continue.
Yeah, I will. Well, I don't think that I can continue going on, but maybe like 10-15 minutes. Is it okay?
It's okay, fine. Yes, sir. You can take your time, sir.
Okay, thank you. So okay, so we'll continue. So now the whole point is that now you can see that the blue color graph is going down and the green color graph is going up. It means that the SSDs are replacing hard disk drives. Now, okay, so well, this is I can share this PPT with you guys. You can go through it later on. So I will try to skip some of these things. These are the comparison between three protocols we discussed, that is SAS, SATA, and PCIe. And now this is an important point. Now you can, oops, not that. So let's say that what is the throughput. Okay, so these are the three, like there are various generation of the PCI, various generation of the SATA and SAS. So sorry, somebody. Okay, so there are you can see that Gen 1 PCI is running in the 1000 MB per second, but at the same time the SATA is limited to 150 megabyte per second. This is basically the protocol itself take the data from the storage and transfer to the cloud servers. So you can see clearly that where we stand at the PCI level, right? The comparison is, there is no comparison at all. The SATA drives are maximum they can go nowadays, like in Apple or they are probably in Apple iMac. They are using probably the SATA drives, which Gen 3 SATA drives, which can give you max 600 megabyte per second. But just take a PCI drive, if a drive which is using PCI transport, and the maximum speed you get is 3.2 gigabyte per second. So now you can do the math, right? That, and Gen 4, the currently just till last year the PCI was at the Gen 3. This year they came up with the Gen 4, and now, not this year, so at the end of last year, so Gen 4, and that is basically they are doubling their speed. A bandwidth is doubling. What is the Gen 4 is 6.4 gigabyte per second, like, and Gen 5 they are planning like in couple of next 2 years, and that is going to be like whole 12.8 gigabyte per second. So if we go back to the users model, now you can see that which protocol is going to sustain the performance. All right, that this is clearly the PCI protocol, PCI transport protocol is going to sustain the performance. Well, here I have used the term gigabit per second. That is gigabit, like a small b is a gigabit per second. That is the transfer rate, and like bandwidth which comes, and if you know that is electrical part, 8-bit and 10-bit encoding. So that is that transform nearly to 100, like 10 times of that. So it is if you calculate in megabyte per second, so like 1.5 would come 150 megabyte per second. Okay, so the question is that, okay, that if protocol is so fast, is there any storage device? So like if you go back a couple of slides, so now we see that in this slide we see that, okay, the PCI transport itself, this arrow, the PCI transport can drive data like up to Gen 4, it can drive to 6.4 gigabyte per second. So what is the bottleneck? Is storage devices fast enough to utilize that bandwidth? We know that hard disks are not. Hard disks cannot transfer data at that rate. But so let's see that what drives we have. This is just we can skip. Same thing like PCI 5 will come at 20 giga transfer, 32 giga transfer per second. PCI 4 is 16 giga transfer. PCI 3 8 giga transfer. So in PCI terminology they call it giga transfer per second. Hello. Okay, so oops, we are coming back. Okay, so these are the two drives. These are two Toshiba drives. I basically work as the architect for CM5 drive, which was basically on the PCI Gen 3, and now Toshiba has come up with the drive which is PCI 4, PCI generation 4, and now you can see the difference. CM5, which is like short form for Condor drives. So Condor M5 was working at 3.3 gigabyte per second. Now the Condor CM6 drives are basically working at around 6.4 gigabyte transfer, uh, 6.9 MB per second, 6.9 GB per second. So you can see the difference. So there are drives which are basically using full bandwidth provided by the PCI protocol. Okay. This is so now this is a PCI Express System overview. Well, so I think that I will. Is it okay that if you guys have some questions, I can take the questions, and I think we are running out of time, and so, or you want me to? So there are too many slides now. I cannot probably think, but okay, let's talk about this slide. This is just a PCI Express System overview, and after discussing this, I will take questions you have, and the questions will not be about just uses, right? That we discussed just uses till now. So I can take the questions if that is okay. Is that okay?
Yes, sir.
It's coming. Okay, so this is a PCI Express System overview. So this you can check your. This is normal. You can open any desktop. So nowadays you will x86 servers. So there you will find this kind of architecture where you will have a root complex where the CPU and the DDR is connected, and there is a PCI endpoint. So PCI endpoint is basically the graphic card. It can be graphic card or it can be SSDs. So that is what it means. And the switch is PCI switch. Switch gives you more ports so that you can connect so many drives to a same system. And CPU can access all these endpoints using through this topology. This is typical x86 server architecture. So now Intel has divided their PCH, basically their motherboard, in two parts. One they called North Bridge, another they called South Bridge. South Bridge is for the lower end devices. For example, you have hard disks, SATA drives, or basically your any USB. But North Bridge is where they attach a very high performing drives. For example, your DDR or graphics card, and nowadays is like they will attach a PCI switch and then attach a lot of SSDs to those. Okay guys, so I think I will end my presentation over here. I will share this. These are some specification for PCI, and you can just give me a minute. So, okay, so this I will share with you guys. Like there are so many slides I wanted, but these are details of the PCI protocols. These are easily available on the net, and you can go through it. We ran out of the time. This is the kind of example which you will find when you are developing a device driver, like for any PCI device. This is very useful information. But so I will end my presentation because of I'm sorry, I'm running out of time. So if you guys have some questions, I'm ready to take questions as well. So
Mr. Devesh, I have one question. Can I?
yeah, sure. So let me. I see a couple of questions which is posted over here. So
First you go with that, then I'll come next. Okay.
okay, Dr. Ritoya,
Okay.
that's fine with me. So I think Mr. Singh asked that, Dr. Singh asked that what is the speed of 5G? Well,
Yes.
sorry, I don't have data that what is the speed of 5G, but I think that it is at least 100 times faster than what we have in 4G. It is just a guess that it is going around 20 gigabit, which roughly comes around 2.5 gigabyte per second. So okay, so that is a very interesting question. So let me go back to how can I go to my slides? Okay, so here is the use case. Okay, so you see the 5G is roughly coming around 2.5 gigabyte per second. But now remember one thing about the 4G and the 4G or 5G is being used in what environment. So these two guys using HoloLens or EVA's headset, they are capable of accessing 2.5 gigabyte data each. So in a given area, you can assume that like how many such devices will be there. So each device is causing 2.5 gigabyte transfer, like fetching or submitting 2.5 gigabyte of data to the cloud storage. So, and now you can imagine that how many 5G enabled devices will be there in a given area. So how much data will be transferred at any given point. So that is like not just 20 gigabyte per second, but it is 20 gigabit per second for each device in a given area. So this 5G enabled devices is going to generate a lot of traffic on existing storage architecture, storage systems. So that is important point. Okay, so is that did I answer your question, Mr. Singh?
Mr. Latoria?
There is just one. There's just one question. Another, Ms. Shivani Desai is asking which one is the better, the SATA or SSD. Well, I didn't get this question because you are asking that which one is the better, SATA HDD or SSD, or this question is not clear to me. So okay. Well, if you are talking about SATA hard disk versus SATA SSDs, then I showed you especially solid state drives are going to be much way faster than the hard disk. Then the SAS SSDs are faster than SATA SSDs by 2 to 3 times, and the PCI SSDs are faster than SATA SSDs around around 8 times, and the gap is increasing, and it will be like maybe too much by around 16 times by 2021. Okay, so any more questions? Yeah, Dr. Victoria, you were asking some questions.
Yeah, the simple question is that what is the role of PCI in robotics field basically? Are they there been any built-in motherboard, or they are using any microprocessor on that?
Well, okay, so let's go here. Like, not. Well, this is so. Now you can see that this is very interesting. So you can see that this root complex itself is a PCI bus. Now, if you look at your desktop and everything, it is, and there is a command called, like, if you are on a Linux system, you can check the PCI device tree using ls PCI, like ls for listing and PCI for PCIe devices. So the PCI transport is too fast. It can basically, it has latency of nanoseconds. So if DDR can be attached to a PCI bus, so at the same time, you know that in robotics, I'm not very expert in robotics, but what I understand that this bus itself, this transport protocol has very minimal latency, so much so that on a server class system, a DDR can be attached to PCI bus. CPU can be attached to a PCI bus. Like, for example, like if you check this one, so this is all interconnect. Now they are defining the PCI interconnects. So in robotics, I think that if you are using PCI, but only problem is that is not a problem, but the cost wise, the PCI transport and related this thing are very costly. So it depends that what your robot is going to do. Is it a real-time system which requires so much fast processing? Then you can of course use PCI technology in robotics as well.
Okay.
I don't know that. Did I answer your question?
Yeah, sure.
Okay, thank you.
Thank you.
Mr. Devesh. Mr. Devesh.
Yeah.
Mr. Devesh, as I know, you are running out of the time, but I have one question.
Sure.
My simple question is, what is the difference between the PCI bridge and PCI switch?
Oh, okay. Let me. Okay, so here, the bridge is basically like how the word is being used. The bridge is basically connecting two ends, right? So, like in this picture, you can see that the PCI Express transport is getting connected with the PCI old legacy PCI drives or PCI parallel PCI drives, which are basically older version of the PCI drives. So two incompatible drives which are talking on a different protocol terms, you need to have a bridge in between them. So basically it is connecting two devices which communication protocol is different. There you require a bridge. But switch is like as you can see here, that switch is basically that you want to, for example, if a if a you have just one socket in your house, and then you connect one big extender to that, and so you have so many points, so many connection points, right? Similarly, the switch is being used. So minute you connect, for example, in this root complex, there is just one slot. So, but you need to connect 3 endpoints to this particular root complex. So you cannot do that because there is just one slot. So you connect a PCI switch, then you have, suddenly you got so many slots, connect more devices to same system. Am I making sense?
Yeah.
So I will recap. The bridge is between two different devices which is communicating on a different communication level. The switch is just give you the extension of points, connection points.
Thank you so much, sir, for such a wonderful and knowledgeable session. Now I would like to call Dr. Bhanu Pratap Singh to see us to give a vote of thanks. Bhanu, sir.
Thank you, Dr. Latoria. I, Bhanu Pratap Singh, on behalf of AURO University and the entire fraternity of School of IT, extended a sincere vote of thanks to our distinguished speaker, Mr. Devesh Kumar Rai. We feel privileged to have an eminent persona from industry with such enriched experience in storage system. I am sure all participants must have benefited for attending this webinar. I would also like to express my gratitude to both the panelists, Dr. Sudarshan Goswami and Dr. Akhilesh Latoria, for their presence and leading thoughts-provoking discussion. I am also thankful to the IT support team, Mr. Suraj Bhan and Mr. Manish, for rendering us with all possible logistic support. Their meticulous planning in organizing this event successfully. I take this opportunity to extend my sincere thanks to all the guest invites who have joined this seminar from across India. I must mention our profound sense of appreciation of all the students of School of IT for their enthusiastic participation. Your imagination is your only limitations. With this quote, we conclude this webinar today. Be in home. Have a good day.
Thank you. Thank you, guys.
Thank you all. Thank you.